Hi, my name is Emmanuel Etsukudo and I'm taking Physics 2211 at Georgia Tech, and this is my lab report. The lab will be split into two parts. The first is about finding the mass of a black hole using a computational model, and the second is about finding a trajectory to escape the black hole, which will also use a computational model. The lab discusses two key concepts. The first being Newton's second law, which states that an object's acceleration is dependent on the net force being applied to an object in the mass of the object. Velocity, which is also related to this, is a function of speed, which uses meters per second as its unit, and gravitational force is an attractive force that exists between all objects with a mass. In this scenario, a black hole to a ship or a planet. The purpose of this lab was to use a computational model to find the mass of a black hole and also the trajectory needed to escape it. On the left, there are four equations which will be used in the first part of the lab. These equations relate to the parallel and perpendicular components of a force, which combine to equal net force. On the right here, there are three equations shown which relate to the second part of the lab. The gravitational force equation, which will then compare with the net force, and then the system for the first part of the lab was a star, and the second part of the lab was ship and a planet, and the surrounding is the black hole. Moving on to my computational model, I wrote the code in Python using those scripts and set the initial conditions. I would love to call the attention to the gravitational constants and the mass of the star as you see here and here. Now for the code itself, I used the equation stated before to calculate momentum and each component, parallel and perpendicular. As you can see on these lines, I calculated the initial and final velocity of the star and delta V and delta P, which I used to calculate dp/dt and use that to calculate the net force using Newton's second law. From there, I used that to calculate F-net parallel and perpendicular and use the total of that to calculate the mass of the black hole overall. You can see the results of the lab and a picture of a simulation of our star moving around the black hole. You got our F net parallel and perpendicular, and use that with the gravitational force formula to calculate the mass of the black hole. Now for the initial conditions. In this scenario, we use the mass of the black hole which we got from the previous part, and we use this in the gravitational formula, and then we now use mod to calculate the plane's velocity and speed as you see here, and finally the ship speed, x and y position, which we go through trial and error to find the scenario where the trajectory of the ship could escape the black hole. Now the code itself is just mainly a repetition of the gravitational formula. As you see here for this example, it's actually just gmm divided by r squared repeated over and over again. For example, we found the gravitational force from the black hole to the planet, the ship to the planet, the black hole to the ship, and the planet to the ship, after which we were able to calculate the final net force for both of them. With the net force, we're then able to use the velocity update and position update formula on both the planet and the ship to tell us if we're able to escape the trajectory of the black hole, which we did. Now for the follow-up questions, what does it mean? How is the net force and its parallel and perpendicular components different? Well, if you remember at the beginning of this video, I said that the PDT and the net force were equal to each other. Well, how does this make sense if they are different? The difference is that in part one of this lab, we are measuring for the PDT and therefore we are concluding that the net force was equal. We just deduced the value of F net. What if instead of wanting to take a quick look at the black hole and leave, you decide that you want to enter an orbit around the black hole? What initial velocity would your spaceship need to have in order to keep in this orbit? For this question, I set the total time to 5 hours instead of normal time I used before, and the velocity I found that create a circular orbit around the black hole is negative 9 times 10 to the 5th meters per second in the x direction and 1 times 10 to the 7 meters per second in the y direction, and it has a full orbit. So thanks for watching.